Alright, the first thing we're cutting here are the tenons. These will combine with the open mortises to form kind of the backbone of this table. I'm cutting these on the radial arm saw with a 3/4 inch dado stack. 3/4 inch is the thickness of the material, hence the depth of the cut. This is what the tenon actually looks like. You'll notice it was only cut on 2 sides, not the typical 4. So now that we have this, you can see I have the quarter sawn, the medullary rays exposed. Those are going to kind of wrap around the legs. So that means I have to pay careful attention to the orientation of everything. Now what I'm doing is, this is the test cut for the open mortise. It's an open mortise because it only has 3 walls instead of the typical 4. Once I did the test, I realized it was a little too tight, so I had to shift the fence a hair. And then you'll see my hand is running along the top of the fence. That is, I'm kind of hooking my fingers around the edge to keep my hand in place, to keep it from moving left down, or more importantly, towards the blade. It's just a safety precaution. Moving back upstairs, now we are over to the mortise press. So this time around I'm going to show you a little bit, well, I should show you the whole setup process. It's just fast forward a little bit. So for this, what I'm doing, another section of the legs has 2 mortises. Yeah, 2 mortises on one of the faces, and 2 of the components have that. So the first thing I need to do, the mortise punch was at a 45-degree angle for something someone else was doing. So I had to unlock it, rotate it, and now I'm moving the table all the way forward to check to see if that's perfectly straight. If it wasn't, one side would be further off of the fence than the other. So now that I'm happy with how straight it is, I'm figuring out how deep the table needs to go. So I want to get the center of the punch to be exactly centered up on this component. So you can see I'm shifting the table forwards and back, and I'm trying to find that dead center point. Once I have that, the next thing I'm going to do is figure out left to right where it should be. With this cut, I'm only doing a single punch. I'm not making a rectangular mortise. It's just one square punch. So it's a fairly simple setup. Here I'm shifting the stop block. That way I don't have to mark and carefully position every single piece. Once I have this one positioned, I can just unclamp it, put the next one in, and punch. Using stop blocks makes setup for repeated cuts very simple. It does take a little bit of time to set up, but you end up saving a lot more time than you would if you had to carefully place every single cut. With the stop block in place, it gets clamped back to make sure it's not going to move anywhere. If it moves, it kind of defeats the purpose of using the stop block. Alright, so before I cut my actual piece, I'm going to do a test run with some scrap. So these are 2 other pieces of scrap that I have. I'm putting some double stick tape on them, and they're going to be used to trap the wood against the table. That way when I retract the punch, it doesn't try and pull the piece off the table. So they just need double stick tape. That's sufficient strength to hold them down. There's 2 of them, one on either side. That way it doesn't try and pull up one side while the other stays down. It'll ensure you have a straight cut and a safe cut. The last thing I need to do is the clamp in the front. It doesn't reach all the way to my material, so I need to get a block to trap it in there. Alright, so right here, now I have to set the depth of cut. I don't want this punch going all the way through. I'm not cutting a through mortise. If I was, I still wouldn't want it cutting all the way through because that would lead to tear out. For this, I only want to go about halfway. So because this is 3/4 of an inch stock, I want this to go a hair over 3/8 of an inch. So now that this piece is cut, now it's time to check the measurements, make sure everything is straight, make sure it fits with correct positioning and all that. Then I'm free to run the pieces and cut all of those mortises. Now that the mortises are cut, I can come back to the radial arm saw. I've changed the setup slightly. Now instead of using 3/4 inch dado stack, I've switched it to a 3/8 inch stack because the tenons are only going to be 3/8 of an inch long. So what I'm going to do is set the depth of cut, do a trial cut, cut all the tenons. As I cut them, I'm going to be testing them to see if they fit in the mortises. The last thing you want is to cut all of them and realize you've cut them too small. Once you've cut something, it's very hard to come back from that. There are things you can do to fix it, like adding shims, but you might as well take a couple extra minutes to test fit before you cut everything to make sure that your dimensions are all good before you cut everything. It'll make your life a lot simpler. Like I said, it might take a little bit of extra time in the moment while you're doing it, but it's going to save you a lot of headache down the road when you go to assemble, and you won't find you have loose joints which need cleanup. Not only does it save you time, it adds strength to the project. If you were giving this to someone 6 months from now, you won't have them coming to you asking why it's wobbling all over the place. So again, it's just make a cut, check the measurements, see if it works. If it doesn't work, make the small adjustments, try and get it to fit as best as possible. You want it to be a little snug, but you don't want it to be so tight that you have to hammer it in. You should be able to fit it in just with manual force. Alright, so here, after I got all the tenons cut, I realized the mortises needed a little bit of cleanup because of the way the hollow tipped chisel works. The auger goes down lower than the chisel, so it bores out more material than the chisel cleans up. So there were a few corners that weren't perfectly square towards the bottom, so I've taken a 3/8 inch mortising chisel. The mortising chisel has straight sides because it is designed to fit in square mortises. I'm just simply pushing down and cleaning up those little tiny corners. I'm not hitting it with a hammer because I don't want to go all the way through. Like I said, I'm just literally cleaning up the corners. There's little bits of material in there that just need to be kind of pried away. Once that's done, then I can actually assemble, and this is the bottom frame of the table. Alright, so continuing on with the radial arm saw, the next thing we'll be doing is cutting out half laps. So for the half laps, I've now needed to switch the dado stack back to a 3/4 inch stack. We want this cut to be wide enough where the entire thickness or width of our material fits through the cut. One thing to be aware of whenever you're changing a blade like this, unplug the machine. Make sure there's no chance for it to turn on. Once that is set up, then you're going to do your test cut, see if your depth is right, see if the width is actually right. Just because there are however many blades on there does not mean each and every blade is its standard original store-bought 1/8 inch thickness. After the blades have been sharpened, they do lose some material, so if one of the blades was sharpened a few times more than another one, it might be a 32nd inch smaller than you think it is, which means your cut is not going to be a true whatever measurement you're trying to get. So in my case, 3/4 of an inch, which is what happened here. So now you'll see me taking apart the dust shroud, and then I'm going to unbolt the blades, and I'm going to be sticking shims in here. For the shim, so a shim is essentially a thin piece of material just to kind of boost the width. In this case, I'm going to be using small scraps of paper. These are designed to go in between the blades. They add something like a 64th of an inch, if that. All they do is space the blade out a hair's width. As they cut, it's not going to leave that hair wood fiber line. What it's going to do is the blades are still close enough that they'll be able to clear out all that material, but it'll just push that edge of the blade a little bit over. That way you can get a slightly wider cut. Obviously, if you had stacked up shims in one place where you have a 16th inch of shims, there's going to be a 16th inch gap. But if you're using a single shim in between two blades, you're not going to notice the difference. All it's going to do is accomplish getting you that slightly wider cut that you need. It's not going to degrade the quality. So here the dust shroud was giving me a little trouble. It wasn't reseating nicely. You want to make sure it's actually seated properly for two reasons. One, this is a steel dust shroud. You don't want the blades contacting this. It will end poorly. Two, if it's not seated all the way down, more of the blade is exposed. You want to make sure it's in the right place. So now what I was doing is I was checking the grain orientation. Like I said earlier in the video, I want all of the quarter sawn medullary rays to actually be showing on the same sides when this piece is assembled. So that means things need to be cut in a very specific order. So here I'm trying to test fit what I just did, and I'm realizing it is still slightly too thin of a cut. So what I'm going to have to do is go back and add another shim. When I add this second shim, it's not going to be in the same place because, like I said before, you don't want to be stacking up shims because that'll be creating a gap in between the blades. What you want to do is take another blade off, stick it in there so that it kind of alternates where it's blade, shim, blade, shim. That will make it so the cut isn't affected by the placement of the shims. It will just be slightly wider. So another thing, when you are putting multiple blades on a stack like this, you need to pay attention to not only the direction they're facing. You want them all to be facing the same way, and they all need to be facing the way that the blade spins, or else they'll be on backwards and they won't be cutting properly. You also want to pay attention to their positioning left and right. You don't want two teeth of a saw blade touching each other. If the teeth are touching, they're going to get hot very fast. They're going to run the risk of chipping, breaking, kind of welding to each other. You want to make sure there's a gap between each of the teeth. That way they can do what they're supposed to do and actually cut through the material, make clean cuts. Your blades will last longer. You'll have nicer cuts. Everything will work better. So when you put on blades like that, you always want to take a look before you tighten everything down, making sure that there's a little gap between all the blades and that none of them are touching. If they are touching, you can just shift them around with your hand before you tighten them. So now that all the cuts are made, now I can dry fit everything, make sure I'm happy with it. And here's a quick look at what the legs, these are interior legs now. You can see all the quarter sawn grain matches up with each other.